All right. In this video, we're essentially going to go over how you would analyze the data for a 2x2 between subjects factorial experiment. So one of the first things that we're going to touch on is how the data needs to be formatted. Then we'll talk about how you would calculate descriptive statistics for this data set. Then go into how you would conduct a two-way ANOVA and then follow that up with Tukey's HSD postdoc test. And then how you would create a graph for this, specifically a bar graph in ggplot. So let's go ahead and look at that data. So the data needs to be in what's called long format, where essentially all of your measurements are stacked in the same column. So the data that we're working with is for a 2x2 experiment that essentially looks at the necessity of something called a marking stimulus. If you were training rats to press a lever, and you delay the reinforcer. So the rat presses the lever and then it has to wait, say, 30 seconds or a minute to get some sugar water or a little sugar pellet, whatever you're using as a reinforcer. But if the rat presses a lever and then has to wait for a minute until it gets the reinforcer, this creates a problem for a lot of reasons that we won't go into. But one of the things that's shown or been shown to allow animals to learn in this situation is if you mark the response somehow. So as soon as the animal presses a lever, you play a tone. And so that's what this hypothetical experiment is looking at. Different rats responded for a reward that was either delayed or immediate. And after they pressed the lever, there was a marking stimulus where either no tone was played, so there really wasn't a marking stimulus, or a tone was played as soon as they pressed that lever. So it's this really basic 2x2 design. And then the dependent variable is how many reinforcers they earned. So for this rat 1, that did not receive a marking stimulus, there was no tone when they pressed the lever, and the reinforcer was delayed, they only pressed the lever 3 times. However, for rat 9, when there was a tone after they pressed the lever, but the reinforcer was delayed, they managed to press the lever 16 times. And then the immediate condition with no tone or a tone. So let's go through how you would actually conduct the data analysis for this 2x2 experiment. So we've gone over the data format. Now let's go for descriptive statistics. So I'm going to use a package called psych, and I'm going to use a function called describeBy. Now, when you use describeBy, when you use describeBy, what it will do is it will give you the descriptive statistics for each individual subgroup. So if I wanted to do this, the first argument that I need to input is actually the data that I want descriptive statistics calculated on. So in this case, it's the marking experiment, and I want it to my dependent variable, which is RFT, which is short for reinforcers earned. Then what I essentially need to do is I need to specify what my grouping variable actually is. Now I have 2 grouping variables, so I actually have to use a list. So group equals, and the function that's going to be equal to is list, and then I list out my different independent variables. So my first independent variable in this factorial design is whether or not there was a marking stimulus. So once the rat pressed that lever, was that lever press marked with a tone or not? My second dependent variable was whether or not there was a delay. So when I run this line of code, here's the output that it should give me. So descriptive statistics by group, and for the group that had no tone and the reinforcer was delayed, N of 8, a mean of 3, reinforcers earned with a standard deviation of 0.76. For the group that had the tone played, marking their response, and the reinforcer was delayed, we can see that that next group of 8 had a mean of 20 and a standard deviation of about 4. no tone, so no marking stimulus, but the reinforcers immediate had a mean number of 25 reinforcers earned with a standard deviation of about 4. And then we can see here at the end when the tone was played and the reward was immediate. So this is how you would get descriptive statistics in this situation. Now let's go on to calculating that two-way ANOVA. Oop, I can't type today. All right, pull this down so we have a little more room. We can see a little bit better. All right, so similar to calculating a one-way ANOVA, what you're going to want to do is you're going to want to save the output of the AOV function. So in this case, let's just call it results. And our results are going to be equal to the output of this AOV function. For this AOV function, the first thing we need to do is we need to specify the formula, which is our dependent variable. And then we need a tilde, and then we need to specify how we want R to model this. In this case, we want to be able to see a potential interaction as well. And so marking star delay. Then we need to specify the data frame where this data is, which is in the marking experiment. So again, you run that, you don't actually see anything. It does actually go here to results. To get the ANOVA table, you need to use the summary function on results. Let's go ahead and give ourselves the ability to see that there. And we can see we have that ANOVA table with our degrees of freedom, our sum of squares, the mean squared, the F value, and the P values for each of these different F tests that you'd have in a factorial ANOVA. So when we look at the main effect of marking, it looks like, hey, that's significant. Just having a marking stimulus may seem to have an effect. Having a delay definitely seemed to have an effect. But critically, the interaction of these two factors based on this p-value of 9.31 times 10 to the negative 7th did seem to have an effect as well. So to really get a picture of what's going on, we really do need a graph of this at this point. Okay. However, before we get there, let's go ahead and calculate some post hoc tests. So, similar to a one-way ANOVA, Tukey's HSD, and then we need to specify results. Now, you can add a second option, which equals, and then you can specify what you want post hoc tests for if it was inside a single factor. So if you wanted to look and say, okay, did just marking have an effect? Now, this is a little silly for a 2x2, but imagine you had something like a 3x5, where for that factor that had 5 levels, you wanted to see if the levels of that factor which ones were different from each other. This is how you would do that. However, in a 2x2, narrowing it down to an individual factor doesn't actually make a lot of sense. So we can just leave it as results. This will conduct Tukey's for each subgroup. So here we have no tone immediate compared to no tone delayed. So inside no tone comparing across delayed conditions. So we can see tone versus no tone delayed is significantly different. No tone immediate versus no tone delayed is significantly different. Tone immediate versus no tone delayed is different. No tone immediate versus tone delayed, there is a difference. However, tone immediate versus tone delayed was not significantly different. And tone immediate versus no tone immediate was not significantly different. So we can start to get this picture, but again, it's really kind of hard to visualize from this. So let's go ahead and create a graph of this. Go ahead, give ourselves some more room. So All right, so first thing we want to do when we create this graph is call up our library. Got our library called up, gives us a message that, hey, these functions from psych are matched. It's not really an issue at all. Now let's go ahead and go about creating this graph. So first thing we want to do is go ahead and save the output of the ggplot function to an R object. All right, and first argument we need here is the data that we're working with. So this would be marking experiment. And then we need to tell R where we want the different variables in this data frame to go. So let's go ahead and set on our x-axis delay, so our first independent variable. And then for our y-axis, let's go ahead and have our dependent variable. Now we need to find some way to represent that second independent variable. And we can do that with the fill color of the different bars. So fill equals marking. Clean this up just a touch real quick. So that first graph, specifically only the skeleton of it, so that when we see graph 1, we can see our y-axis, we can see our x-axis. We have some labels there. We'll need to update this eventually, but we've got to start. Now we can go through adding the different layers. The first of those is going to be something to represent the means. Let's do stat summary. Calculate those means to start. So a function of y is going to be our mean. And we want to represent it with a R. Now, let's go ahead and look at how this looks right now. One thing you'll notice is that it doesn't really look how we want it to start. We can't see a second bar for the no tone condition and delayed. When we look at the immediate condition, they are stacked on top of each other, as it were. What we really want to do is essentially make these bars not overlap and, quote, dodge each other. So we need to set the position of these bars. So inside the stat summary function, position equals position dodge, underscore dodge. And then inside this function, we need to set how far we want them to dodge. So if we set it to, say, 0.5 and then ran it, they would be overlapped almost half, so to speak. If we go with 0.9, this gets it to where they're just barely touching. If we go with 1, we'll have a small gap between them. For our purposes, let's go with 0.9. Now we'll need to replicate this code when we actually create our error bars, which would be our next step. So let's go ahead and represent our error bars. So add a little plus sign to the end of that stat summary function to tell R to keep adding to this graph. So we would like to represent our standard error of the mean. So we need function.data, which is a function of data, so fun data. And then we need our mean underscore SE for standard error. The geometric object that we want to represent it as is an error bar. Now, I already let you know that we'll need to replicate position dodge as well, but just for kicks and giggles, let's go ahead and see what that would look like. So they're super wide, and they are all lined up on that center line. So we need to adjust that. So first thing, the position equals position dodge. So you'll want to mirror what you did earlier. Work for me there. Did I accidentally? I'm not sure. Let's go with it. And then we need to set the width as well. Could not find position dot. Okay, that's why. It's because I have a typo. Let's try that on for size. There we go. So now this is starting to look like a graph that's actually representing our results. And we can see, hey, immediate condition, it doesn't matter whether you have the tone or not. In the delayed condition, it makes a pretty big difference. The next things we need to do are really sort of aesthetic and getting this graph presentable. So one of the first things that you might want to do is actually change this y-axis label to something that isn't shorthand. So let's go with the function, add a plus sign to let R know to keep adding, ylab, and then specify what you'd like, reinforcers earned. All right, now, because we have multiple colors, we can't set the fill color in here or it'll just overwrite everything. We could, if we wanted to, add a border. So like if we wanted to add a black border to the bars, we can add that black border, but to change the fill colors, we actually need to use a different function. So that would be scale fill manual. Okay. Now we can change the name on our legend too. So this will also affect the legend. So if we want to change our legend name, marking stimulus, we can set individual values to represent that color as well. So labels equal to no and yes. Now we're at where we can go about changing those colors. Values equals, and let's go ahead and make this first bar white, and the second one, let's make it sort of a goldish yellow. Instead of just the word white, I'll actually use an HTML color code, FECB00. So now I have these white and yellow bars, and from there I can go ahead and add a theme and clean it up some more. Now you could, if you wanted to, go through, look at two keys and see which means are significantly different and which means are not. However, when you start getting more and more significant differences, more and more bars on the graph, and potentially more and more lines, there is a point of diminishing returns. And so for this graph, we're not actually going to draw out all those lines to represent those significant differences. And part of it is because when you look at this interaction, it's pretty obvious. It looks like the main effect of a marking stimulus and the main effect of delay are both probably driven by this interaction where when you have a delayed reinforcer and you don't have a marking stimulus, nothing really happens. The animal doesn't really learn anything. The animal's not motivated to work for that reinforcer.